Okay, so welcome back, Math 20-3 and 30-3s. Today, as part of the intro, we're going to talk about converting units. So often in math, different questions come with different units, and the first step is often converting to a different unit. Not all the time, but often comes up in math courses where you have to switch to a different unit to solve the problem. And so it's really important that we understand this and get it right consistently and know how to apply this process so we can continue the rest of the problem. And it's not really that hard, as it plays off of some similar algebra methods that we kind of saw in the last review. Which we see here is that the numerator and the denominator, when you have the same number in the top and bottom, they're going to cancel out because that is ending up being equal to 1. So just for example, if we had 2x over 2, we have the same number in the top and bottom, they cancel out. Also, another way that we could say this is that that makes it equal to 1. So when we had that 2x over 2, that could be written as 2 over 2 times x. 2 over 2, when the number is the same on the top and the bottom, it's the same as 1. 1 times x is equal to just 1, which it says on the next slide, when multiplied or divided by 1, the number stays the same. So really that method of canceling tells us three things. Top and the bottom cancel when it's the same value. As long as we have the same value on the top and bottom that's equal to 1, and when you times something by 1, it's not going to change the value, or if you divide it by 1. So let's see how this applies to unit converting. Okay, so you'll start by writing down the given unit that you have in the question, something like 10 centimeters. Then you write an empty set of brackets, so it looks like this. Empty set of brackets with something on the top and something on the bottom, but it's just empty so far. And then you place the unit that you want to cancel in the denominator, all right? And then you place the unit you want in the numerator. Lastly, you make the numerator and the denominator the same value because that won't change the whole equation since it's just 1, and then you're gonna solve the equation. Yeah, that was probably pretty confusing looking at notes. So let's show this with an example. I think it's going to make way more sense. So I'll put all those notes up here, and we're going to say how many meters are in 10 kilometers. So the first step, we're going to begin with the unit that we have. So 10 kilometers. All right, the next step, place an empty set of brackets like this. And so we're going to imagine that 10 is in the numerator. So I've written it kind of at the top here, and then an empty fraction. So this is the line here, we have numerator at the top, denominator on the bottom. It says this is going to cancel the unit we want to get rid of. We want to get rid of kilometers by placing that same unit that we want to get rid of in the denominator. So that means on the bottom here, km. So what we're learning from this is, remember, things in the top and in the bottom will cancel each other. And we haven't put any numbers in yet, but if I have kilometers times something with kilometers on the bottom, it's going to get rid of that unit. Just like we got rid of numbers before, kilometers are going to cancel. So we're done that, and now the next one says place the unit you want in the numerator, and it said how many meters, so I'm going to put meters on the top, and since kilometers are now gone, they're canceled, that's what my answer is going to be in. Now that next part, we can't actually change the value of 10 kilometers. We can't just times this by 2 and that's going to change the value. We have to make whatever it is in brackets here equal to 1 so that that value of 10 kilometers, that distance of 10 kilometers, can't make it with my hands, it's really, really big, but 10 kilometers has to stay the same. We can't change that value. So whatever's in the brackets has to be equal to 1. And this might be the tricky part. We have to know how many meters are in a kilometer. And we know that there are 1,000 meters in 1 kilometer. That makes this whole thing in the brackets equal to 1. And I take that value, 10 kilometers times 1, and I still have the same amount. I'm just going to have it in a different unit. Okay, so that's done, and now I just got to solve the equation. So let's just look at the numbers here. I'll switch to red so we can see this. We go 10 times 1,000 divided by 1. And remember, dividing by 1 doesn't really do anything. So it's just 10 multiplied by 1,000, and we get an answer of 10,000 meters. Now you probably would have thought, well, I know there's 1,000 meters, so I'm just going to times by 10 anyway. That's totally fine, you can do that, but often people get mixed up. Do I divide by 1,000 or times by 1,000? This is going to help you with that. I'm going to show another example as this method applies to converting any units. Okay, so this next one a little bit trickier. This might be used for baking or cooking. How many milliliters is in 1 1/4 cups or 1.25 cups? We'll start with the given unit, 1.25 cups. All right, and then next we have to do an empty set of brackets. So I'm going to put it like that. And we're going to put the unit that we want to cancel, one we want to get rid of, in the denominator. So I'm going to put cups right there. Next, I'm going to place what I want in the numerator. I want it to be in milliliters. And now that tricky one, you might have to look this up maybe on Google sometimes, what are equal to each other. But we know that there is 250 milliliters in 1 cup. So that makes that equal to 1. Now we just solve 1.25 times 250, and we'll get our answer of 312.5 milliliters. Now, when I mentioned that you might have to Google how many cups and how many milliliters, you might have thought, well, if I'm in Google anyway, I can just put in 1.25 cups and get that number. And you are absolutely right. The only thing is you won't be able to have Google on some tests. Is that a good explanation for why I need to learn this? Not necessarily, because in a job you'll probably have Google as well, but this does help in cases where you don't have internet or there's going to be conversions that are not as easily looked up. And just these operations for math help us to estimate or even make conversions in our head when we don't have access to technology like that. But I do hear you, lots of times you will have the internet, and the internet has replaced this skill for a lot of people, which might be okay. If it's not needed, you can focus your brain power on other things, but right now it's still often used in questions and on tests, so you're going to have to learn it. The other thing that it helps for is if you're in any physics classes or even chemistry classes or other science classes that you have to track the units throughout a question to make sure you're doing it properly, that can help there as well. And in chemistry, unit analysis can help you convert or even just solve problems without a formula as long as you know how to use these units. So this basics can be applied to some other places as well. But that's it. That's all we have for this intro video. If you could try those practice questions the next day after you watch this video, and then I'll be available on the Google Meet for answering those questions. So I will see you in the next class.